Recording in progress. Hi, students. In this lecture, I am going to discuss some more problems based on plane mirrors. Let us see. Let's see the question. As shown in the figure, a particle is placed at O in front of a plane mirror M. A man at P can move along the path PY and PY dash. Then which of the following is true? See the options. He can see the image only up to a distance d on either side of P. For all points on Py dash, the man can see the image, but on Py, he can see image. Okay, let us do one thing. Let us make a diagram, then we can decide the options regarding image. Regarding image, let us make the given diagram. So it is given a mirror. This is mirror. And we are placing an object. Placing an object. So you can see here the location of object. This is location of object, right? It is O. Now a person moves. A person moves along. So this is given P, Py, and Y dash. Moving along this y-axis. Okay. Let us see up to where he can see the image. Okay. That means we have to focus light rays coming from the object after reflection are reaching up to what region? See here, light rays coming from the object falling on this extreme, on this edge. On this edge, if you see carefully, normal drawn at this edge means at this point. If you draw normal, according to the diagram, see dimensions given here. This is a D. This is also D. That means this angle is 45. This also 45, right? That means angle of incidence. This is now instant light ray. This is angle of incidence. Angle of incidence is 45. Then angle of reflection also 45. That means light rays will become now parallel. Light rays will become now parallel. Means horizontal, okay? Not parallel, horizontal. Now they are becoming horizontal. This is now reflected ray. Okay. Initially light rays vertical, okay, falling at this point. Angle of incidence 45. So angle of reflection also 45. That means light ray becomes horizontal. Means light rays after reflection reaching only up to this point. So person can see up to this point, right? Beyond this he cannot see. So basic condition is if you want to see image, light rays after reflection must reach our eyes. So light rays are reaching only up to this point. Okay. Now see here on this edge. This is now instant light ray. This angle is 45. I can take here normal. So angle made by instant light ray with normal, that becomes now angle of incidence, that is a 45. So angle of reflection also, it is 45, right? That means now light rays will become, they become vertical. Okay. That means see carefully, this also 45 only, vertical. Light rays are parallel to y-axis. Parallel to y-axis means now this light ray will meet the screen at infinity. The meaning of infinity is it never touches the screen. Okay. So remaining light rays will reach the screen. That means the person can see image up to infinity on py dash because this light ray is now touching the screen at infinity. That's why he can see image up to infinity on py dash. But coming to on py, he can see only up to distance d because beyond d there are no light rays after reflection. Okay. Now see options. So for all points on py dash, he can see image. But on py, he can see the image of O only up to a distance d from P. It is option B, right? All points on py dash, but on py only up to distance d. Option B is correct. Coming to A, he can see image only up to distance d on either side. That is wrong. For all points on py dash, the man can see image, correct only. But for no point on py. So this is wrong. Okay. So first half correct only. For all points, the man can see image. Okay. For all points on py, the man can see the image of O. So this is wrong. So option B is the correct. Okay. Let us see next one. A plane mirror is placed with its plane at an angle of 30 degree with y-axis. Plane of the mirror is perpendicular to xy plane. So you have to visualize carefully how the plane is, okay? How the mirror is placed. Given mirror is making angle of 30 with y-axis. Plane of mirror is perpendicular to xy plane. Okay, that means here how it is placed. It is placed. That means first imagine mirror is placed in yz plane. Okay, first imagine mirror is placed in yz plane. Okay, now rotate the mirror. Rotate the mirror anti-clockwise by 30. Then this plane of the mirror makes angle 30 with y-axis. I hope you got the clarity. So what I'm saying is first imagine plane mirror in yz plane. Now rotate the mirror by an angle 30 anti-clockwise. Okay. Then we get this structure, okay, this figure. Okay. Now see carefully. Length of the mirror is 3 centimeter. An insect moves along x-axis starting from a distant point with a speed 2 centimeter per second. Find the duration of the time for which the insect can see its own image in the mirror. Okay, let us see how to get it. Right, let us make the diagram and see the given data. And you can see here So this is given as x-axis and this is y-axis. Let us take now mirror. So mirror is making angle 30. This is making angle 30. Okay. Now, given that, and one more thing, length of the mirror is 3 centimeter, and its velocity given 2 centimeter per second. Right. Let us see carefully here. The meaning of, let us make length of the mirror a little bit smaller to make diagram clear. Suppose this is now mirror, okay, length is 3. Now see how long the insect can see its own image. So insect can see its image if light rays falling on the mirror after reflection reaching its eyes. I am repeating. The insect can see its image if light rays falling on the mirror after reflection reaching its eyes. Okay. Now you are given length. I am taking a normal for this mirror. Let us draw normal. So this is 90. So this is a mirror. Now see carefully. If insect is beyond this point, let us call this as O, and this is A, and this is B. You just imagine insect is now left of point A, left of point A. I will make one more diagram to make it clear. Right. I am taking a normal to the mirror. This is A, this is B, and this is O. You just observe if insect is left of point A, light rays. For example, I'm taking somewhere here. This is insect. This is now insect. If it is somewhere here, light rays falling on the mirror. You can take falling anywhere. After reflection, they're coming like this. You can see after reflection, rays are not reaching its eyes. You can see you can take any point left of point A. It is any point left of point A. Light rays falling on mirror at any point on mirror, they cannot reach the eyes of the insect. Okay, you can take any point left of A. It can fall at any point on the mirror after reflection, not reaching the eyes of the insect. So I'm taking like this, reflecting. Next, falling here, reflecting. So not reaching its eyes. Now take one more diagram. One more diagram. Now consider after reaching point A. Okay. Let us see. Again, I'm taking here normal. I'm taking normal here. This is a point A. Now focus from point A up to point O, what happens. Okay. If you observe carefully, take a light ray, take a light ray at point A. Light rays falling at each and every point on the mirror. Okay. But out of those, if you see here, the light ray falling on this edge, it falls normally. It falls normally. That falls normally, it will retrace the path, right? So I'm taking here at point A. It falls light rays. You can see light rays like this, not reaching its eyes. But if I'm taking a light ray normal to mirror at point A, normal, falling normally, it will retrace the path. That means this light ray is reaching its size. That means now insect starts seeing its image. I am repeating. At point A, I am focusing one light ray which falls normally on the mirror, means on this edge. Since it falls normally, it will retrace the path. So this light ray is reaching its eyes. That means insect can see its image, and because of the remaining light rays it cannot see image. Okay, it sees image only because of this light ray, right? Now if I'm taking somewhere here, you can take any point in between O and A. I can always take one line or one light ray instant normally on the mirror, and that is retracing the path. I will make one more diagram here to make it more clear. So I'm taking here one more point in between A and O. You can take any point in between these two. Let us take here one more. I'm taking somewhere here. I'm focusing one light ray which instants on the mirror normally. This light ray will retrace the path. Because of that light ray, it is able to see its image. If you focus remaining light rays like this, reflecting, not reaching its size, right? Next, if you take light rays like this, reflecting, not reaching its size, but this light ray which falls normally, retracing and reaching its size, that means from A onwards, we can take one light ray which is instant normally on the mirror, and because of that light ray, it is able to see its image. That means it starts seeing its image after reaching point A until reaching point O. Okay. Therefore, we have to focus now this AO. Now see what we can do. Length is given 3. Now time taken means how much time it can see its own image. That means time taken to reach point O from A. Length of AO upon speed. Speed is now 2 centimeter per second. And see what's the value of AO. This is 30. This is now 60. Okay. Then this also 30. So we want now AO. We know opposite side. So I can take sine 30. Sine 30 equal to opposite is 3. 3 by AO. Right? AO is now hypotenuse and BO becomes opposite side. Sine 30 equal to. That means AO is equal to 6 centimeter. So AO is 6 centimeter, and this is now 2 centimeter per second. It is equal to 3 seconds. That means it can see the image for 3 seconds. If they ask like from which point, if I draw normal from this point A to here, from point A onwards, it is able to see its image up to till reaching O. That means it is able to see image because of one light ray which incidents normally on the mirror. Okay. So this is our final answer. 3 seconds. Let us see next one. Let's see the question carefully. Two blocks, each of mass m, lie on a smooth table. They are attached to two other masses as shown in the figure. The pulleys and strings are light. An object O is kept at rest. on the table, the sides AB and CD of the two blocks are made reflecting. The acceleration of two images formed in those two reflecting surfaces with respect to each other is. Okay. So he is saying that you can see here M 3M. From Newton's laws of motion, directly we can say for these two blocks, what is acceleration, right? And for these two blocks also. Let us see now. We have to calculate acceleration of two images formed in those two reflecting surfaces with respect to each other. Okay. So first focus here M 3M, M 2M. Let us calculate their accelerations. Let us make a diagram first. Given here M, this is 3M, this is also M, and this is now 2M. Okay. So first we have to make what will be their accelerations. Okay. See how to get it. In Newton's laws of motion, we have learned how to get their accelerations. I will make one's calculation. You can see on this tension. Let us take tension as T1. Then this also same T1. For this one, 3M block forces weight downwards, tension upwards. Net force 3mg minus T1. That is equal to mass into acceleration, take it as A1. Okay. Coming to this one, the only force is the tension, right? Horizontally, not vertical. Horizontally, only one force is acting. So it is now T1. That is equal to M into A1. Okay. If you take sum of these two, T1 gets cancelled. So 3mg equal to 4m into A1. So A1 equal to, that is 3g by 4. Okay. Direction is left side. In the same way, coming to for this one, 2mg, let us take tension is T2. Then this also T2. Okay. 2mg minus T2, that is equal to 2m. Take acceleration as 8. Next, for the block. For the block, there is only one force acting horizontally. That is T2. So T2 is equal to m into 8. Take sum of these two. T2 gets cancelled. 2mg equal to 3m into A2. So A2 equal to 2g by 3. Direction, it is right side. Okay. So we got accelerations for the blocks, right? Now we can see because of motion of the mirror, because of motion of mirror, velocity of image will be twice the velocity of mirror, right? So we got velocity of image is twice the velocity of mirror. Getting it? This is what we have learned in earlier lectures. That means if I differentiate this, I will get acceleration of image is equal to twice the acceleration of mirror. So here object is not moving and mirror has velocity normal to its surface. Okay. That means for image acceleration will be acceleration of the image will be how much? Twice. Twice means becomes how much it is? Into 2. 6g by 4. Direction. Direction is same. Okay. It is left side. That means it is how much? 3g by 2. 3g by 2 left side. And coming to here, acceleration of image. Take it as this is 1 and this is 2. That is equal to, it becomes now twice. So it is a 4g by 3 right side. So we got accelerations for images. Okay. 3g by 2 left side. 4g by 3 right side. Okay. Now we want relative acceleration. So A relative, that is equal to, one is left and one is right. So it becomes now 3g by 2, 3g by 2, 3g by 2 plus 4g by 3. See carefully how much? 3 3 is 9. 9 plus 8, 17. 17g by 6. This is acceleration of image in one mirror with respect to that in the other mirror. Okay. So this is our fan laws. Okay. That means question is now linked with mechanics part. So we have to calculate accelerations. Right. Let us see the next problem. So answer is option C. Okay. Option C. See the next one. A man of height h is standing in front of a plane mirror. Find the minimum length of the mirror so that he can see his full image. Okay. A man of height h is standing in front of a plane mirror. Find the minimum length of the mirror so that he can see his full image. See carefully how to start the problem. Let us make a diagram. Let us make a diagram for this one. Suppose so he is a person. Let us take now mirror. Let us take now mirror here. Mirror is now like this. See, condition is that he should see his full image. Okay. So full image means he can see top of his head and his feet also. If he can see his feet and his top of his head, that means he can see his full image in the mirror. Now see what I am doing. Let us consider his eyes are now somewhere here. Just to make it more clear, I am taking eyes are here. In fact, distance of eyes from top of his head, that distance will be very less. Okay. Just to make a diagram clearly, I have taken somewhere here eyes. Now see carefully. To see his top of his head, top of his head, light rays. See carefully diagram. Condition is that light rays coming from top of his head after reflection should reach his eyes. Okay. Should reach his eyes. So here what I am doing is I am taking midpoint of top of his head and eyes midpoint. So why midpoint means because angle of incidence equal to angle of reflection. Okay. So now what happens is rays coming from top of his head, top of his head. So coming like this. After reflection, reaching his eyes, reaching his eyes. This is angle of incidence and angle of reflection. Since these two are equal, from here to this point and from midpoint to here, means I am saying from eyes to top of his head, take distance as x. Then this is top of his head, EH, take this as J. So in diagram, HA should be equal to AE, midpoint, because angle of incidence, angle of reflection, both are same. Okay. Next, let us consider from feet, height of his eyes are, take it as y. This is y. Again, I'm taking midpoint of these two, midpoint of these two. Light rays coming from his feet, from his feet, of the reflection should reach his eyes. So I'm making diagram from his feet, reaching, and after reflection reaching his eyes, then he can see image of his feet. See carefully, rays coming from the feet after reflection reaching his eyes. So he can see his feet, rays coming from top of his head after reflection reaching his eyes. So he can see top of his head, right? Now, suppose this is B. So in diagram, EB is equal to, take the feet, is equal to BF. Okay, EB equal to BF. That means we require a mirror of length. That length must be, so rays are touching at this point. Next, touching means instant at this point. Let us call this as A, B, take it as a C, and this is D. We want a mirror of length CD. We want a mirror of length CD. This is the minimum length. And see length of CD how much? We can see the length of EB. EB value, EB equal to BF, that is equal to Y by 2. Next, HA equal to AE, that is equal to X by 2. That means length of CD, that is equal to X plus Y by 2. See carefully, AE plus EB, X plus Y by 2 is a height equal to X plus Y. This is now half of his height. That means we require a minimum length is half of his height. Then he can see his full image. So it is making the diagram carefully. Seeing his feet means rays coming from his feet after reflection reaching his eyes. Seeing his top of his head, rays coming after reflection means rays coming from top of his head after reflection reaching his eyes. So with those points, we are making the ray diagram. And remaining is just following the geometry. Then we get that minimum length is equal to half of his height. Okay. I hope you got that clarity.